welcome back to my channel where I'm building a RANS S21. It's been a while since I've got some content out. I've been building and chipping away a little bit at a time. I've got enough content for a couple videos, but we'll get this one out. It might be fairly short given the content. My disclaimer, remember these are not instructional videos, especially at this part of the build where there's very little instruction, a lot of research, and you do what you research and find out. So these are not instructional, but just documenting my build. Others may have interest in it. In this episode, I work on the spinner, the hub extension, or prop extension, and it's not a lot, pretty straightforward, 10 or 15 hours worth of work, but I wanted to get some content out and try and get some videos. So with that, let's jump in and get that spinner completed. This is where I am right now. I've got these two sensors mounted. They're loose right now, and I'll set them when I put the flywheel on. And there's a method. The distance apparently is one thin washer plus the tape on it would be the distance to be set. So I'm going to bring that up to the flywheel, but I'll do that later. Then I ran it through here. I cut a little access area, put some loom on it, and then Adele clamped it, brought it over on top of my fuel feed, and then I cut a grommet pass through. There was a cut already here. I just extended it down and then split the grommet, put it around the wire, because this wire's I can't get the grommet on it, and everything's installed on each end. So I cut the grommet in a slice, put it over the wire, put the cut on the bottom side, and drilled out a hole for the grommet, and this is the access. And that, I think I'm happy with that. And then of course that thing goes into the firewall and to the connection. The gap for the mini sensor face to the flywheel is between 0.030 and 0.060. My buddy who builds says a thin washer with some tape on it is about a 0.040, and that fits within the range. So what I did is I taped on a thin washer with the masking tape, and then I tightened these enough so that this could move, pull them all the way out, put my flywheel on, and that then pushed them in, I'm hoping, to that setting, and then tightened these up. So that's the process I used, and I'm going to double check it before we go further with an engine guy. At this point in the build, there's a couple different directions I can go. I think I'm going to get started with the spinner, then the cowling, and then the engine baffles after the cowlings fit up. And then from there I can start working on some of the closeouts behind the seats and get that done. But let's get the front work done first. So with the spinner comes packaged with this base. This spacer, I think this is called. Again, don't know much about it. I'll have to learn about it. It comes with some bolts, the manufacturer of the spacer, and then RANS provides some diagrams and some figures. So we'll see where we go from here. The next step is to set up the template for cutting the spinner for the prop. And I saw Derek Kenny come up with this idea, and I like it. He cut a piece of wood or a piece of cardboard, exactly 12 1/4 squared off, drew the lines from corner to corner, which gave you the center. Then as you place this exactly on the spot, it's not, I'll be more careful, but just to give you the idea, then these lines where you mark this mark here and the same on the other side will be exactly 180 degrees from each other and perfectly centered. I have cut out my template, which is here, and then I've drawn a straight line to the top, and then I marked here the 3.53 inches, my little X, that'll be my centers. It's 8.97 centimeters, which was easier for me to measure. So that's going to be the center cut for my circular cut, which they say the radius is 1.875. So I need a 1.875 radius around here, and then it cuts straight down to the bottom of the spinner. Be careful in using this template to draw your radius. If you're not using a compass with the exact distance in there, this is saying the distance is 1.875 inches, which is 47.625 millimeters. When I put this ruler up, it's at 45 millimeters, not 47. So the template itself, maybe due to photocopying when I printed it out, is not exactly the right shape. So use a compass or some method for measuring this out, 47.62 millimeters or the 1.875 inches to get you the correct radius. Okay, I've marked my cut, given the template and everything they're telling you to match up and to line up. Trying to determine what tool to use. My Dremel has been pretty good, but I think I'm going to use my jigsaw based on the carbon material and that I've got a pretty good line with the jigsaw, so I think I'm going to cut it with my jigsaw. I did use a jigsaw and I think I'm happy with my cuts. I'm not sure if they have to be absolutely perfect. They look good from the eye. They measure out correctly, so I think I'm good with that. The next set of directions say to put the backing plate on the extension, which is this. That fits on. Then the prop hub fits onto the backing plate. And then they say test fit your dome. So I've got this clecoed so that it's just flush with the backing plate all the way around on both sides. And it looks, you want 3/16 of an inch between the cut and the prop, but they haven't told you to put the prop on. And then later it does say you may have to install the props to get the fit around. So I've taken my propellers, my props out of the box for the first time. They're beautiful, absolutely beautiful. And these are ground adjustable, I think 82-inch ground adjustable. So I am going to put them into the hub and test my cut on my spinner. I've rotated the blade in the hub, and I seem to have enough clearance, even in the most extreme, which it would be like a feathering, but you would never set your prop to a feathering. So for the most reasonable settings, there's clearance on either side. Did the same here. I did have to grind this just a little bit right here to give this enough clearance. But again, that's almost in a feathering position that it gets that close. So I think I'm good. I'm going to continue with this, assuming I'm good. But this is pretty easy material to sand a little bit. If after I set it, I don't like it. So we'll go forward for here. And I've temporarily clamped it where it's flush along here, tight on the sides. So I think that's how it will sit. The next thing in the instruction says remove the dome. Mark holes on the dome's perimeter for 5 screws, evenly spaced. Well, that doesn't make a lot of sense. The parts page shows 10 nut plates, 10 screws, and if you had 5 screws, you'd only have 2 on one side and 3 on the other. You couldn't evenly space them. I'm assuming it's got to be 5 and 5. It's got to be 10 screws. That's what everything else is calling for. So I'm gonna call foul on that and say that's another error in the manual. So I'm gonna space them for the 10 screws. I've got the nut plates, I've got the screws for 10, so I'm gonna do that. Okay, I put 5 marks. Each of the ends are 3/4 of an inch in. That left 14 inches between the 2 ends. Each of these is 3.5 inches apart from the other, and that gives me my 5 on each side. I'm going to drill them out to a 40 to get them started, and then match them up to the plate, and then get the nut plates put on to the base plate. I've match drilled number 40 hole all the way around in the 10 marked holes that I've got, and clecoed per the instructions. I've upsized the holes twice to a number 30 and now to a number 11. So and clecoed per instructions. The next thing I did is I put the 10 nut plates in, and you have to countersink these to make them flush, and you used a 3/32. The directions actually call for a solid rivet to be hammered in, but the newer parts list shows the 3/32 pulled rivets. So it's kind of the way we've done the other nut plates, but these are countersunk into the carbon fiber a little bit. Well, it's January 1st. Time to get back working on the plane again. I've got to kind of pick up where I've left off and actually try and put together where I did leave off. I know I've got something to do with the RPM sensors getting plugged into the ignition panel down here. I've got to check some sensor wires, and I've got my manuals over here. And then over on my workbench, I've got the prop and the new hub, which I know is kind of where I left off. So between finishing the wiring right here and then jumping onto the prop and the hub, I think that's where we'll get started. So this is my replaced prop extension that I got from Sabre Manufacturing. They had to send me a new one with these pins are a little bit different. Apparently, Continental has changed the configuration of their engine mount, and they've, between RANS and Continental, they haven't really gotten it straight, and Sabre still produces and provides the older one with the kit. And when it didn't fit, I talked to him. He said he was well aware of the situation, send it back, and it cost me $70 for shipping back and reshipping and shelving costs. So this is the new one. I just set it up. It does fit pretty well, and they sent some 2x4 bolts. I loosely fitted on the new prop extension. It does fit. I didn't put these in all the way. It does fit and matches up with the engine flange. Got the flywheel in, the spinner plate, and then the prop hub. Again, I didn't put the blades in. It looks like you're going to need two people to do that, and it's not the right time to do it. Just wanted to fit it up and make sure it fit, as the other one did not. And now I think I move on to the cowling. Well, that's probably a good place to stop and get some content out. That section took 10.3 hours. That brings my project to date to 1261.3 hours to date. And that does not include a lot of the research and downtime. That's actual build time. In the next episode, I get started on the cowling. And we move on from there. So thanks a lot for watching. And remember, dream it, just build it.